What is up, everybody? All right, getting into Unit 5. Sticking with triangles. We're going to be with triangles for a little while longer still, but we're getting into more specific types of triangles now. So today we're talking about isosceles and equilateral triangles. So we've already talked about these triangles this year already when we were learning to classify triangles back in Unit 1, way back in August. But now we're going to learn some different properties of the isosceles and the equilateral triangles to help us find different angle measures, different side lengths, and stuff like that. So remember, an isosceles triangle, at least two sides are congruent. So if we take this diagram on our right-hand side, okay, we call those two sides that are the same length the legs. Now, we also talk about legs in right triangles, all right? The legs in a right triangle are the two sides that make the right angle. So leg has a couple different meanings depending on which triangle you're talking about. So in this case, in an isosceles triangle, the two sides that are the same length are called the legs. Then we have normally our three angles, 1, 2, 3, right? And the angle between the two legs, we call that the vertex angle. And again, guys, these are all terms that we've used already, but now we're specifically applying them to an isosceles triangle. The two angles that are not between the two congruent legs, we call those the base angles. And the side that is the different length, we call that the base. So just one more time, just to review that. The two sides that are the same length are called the legs. The angle that's between those two is called the vertex angle. Then the third side that's not the same length, we call that the base. And the angles that are made between the base and the two legs, we call those the base angles. So what do we know about isosceles triangles based on knowing that they're just isosceles, right? Just that two sides are the same. Well, the first thing is that if AB is congruent to CB, so again, this is an isosceles triangle now. So AB is the same length as BC, which makes angle 2 the vertex angle. Angle 1 and 3 are our base angles, and side AC is the base. So if you know that AB is congruent to BC, you can conclude that angle 1 is congruent to angle 3. So what that theorem is stating is that if it's an isosceles triangle, then base angles are congruent. Now, on the converse side of that, so I have triangle WXY and angles 4, 5, and 6. If I know angle 4 is congruent to angle 6, so now I have two congruent angles, okay, aka base angles, then I can conclude that WX is congruent to YX. And so technically what this is showing us is that there's two ways to determine if something's an isosceles triangle. The first way is if you're given two sides being the same length. The second way is if you're given two angles or being the same measure. And kind of a hint here, guys, is that in a triangle, if two sides are the same length, then the angles opposite those sides are going to be congruent. So see how angle 3 and angle 1 are opposite AB and BC. And the same thing's true for the second one. If two angles are congruent, then the sides opposite those angles will also be congruent. And that's true for any triangle. And we'll get to talking about how do we know which side is bigger in a triangle or which angle is bigger. And it's all in relation to the size of the side length or the angle measure. Okay. So let's look at a little diagram here to kind of review what we just talked about. Notice on the left, you know that side FG is congruent to side FJ. And on the right, angle G in this triangle right here is congruent to angle J. So the question is, named two unmarked congruent angles and named two unmarked congruent sides. Maybe pause the video here for a second and see if you can name those four things. Okay, so as we look at this, all right, I'm going to focus on triangle GFJ right here. So I know that that's an isosceles triangle. Guys, one of the key things is going to be able for you to isolate certain triangles within diagrams. So it's almost like I'd be taking this line away, but you can't just take it away. You have to just see it without it. So again, looking at this triangle, FGJ, I know that that is an isosceles triangle because of this segment and this segment. So what I'm thinking is which angles are opposite those sides, or which are our base angles in triangle FGJ. Well, if I look across, it would be this angle here, and look across, be this angle here. So angle FGJ is congruent to angle FJG. Okay. So again, guys, that would be this angle and this angle here. Looking for two sides that are congruent, that aren't marked. We now focus our attention to triangle GHJ. And it's the same concept. We have two congruent angles, so we're looking at the sides opposite those angles. So that would be side GH is congruent to side JH. And that's all there is to it when it comes to finding missing parts of isosceles triangles. And it really comes down to, like I said, your ability to dissect the diagram and find the information. Okay? Let's now look at equilateral triangles. So, quick review, equilateral triangles, that means all sides and angles are congruent. And remember, guys, if all angles are congruent, and we know that all triangles, the sum of the angles has to be 180, then that means that every angle in an equilateral triangle is 60 degrees. Every time. Okay, now the sizes can change, but remember when we talked about dilation, when you dilate a figure, it stays the same shape, so the angles stay the same measure. All that's changing is the size. Okay. So each angle measure, like I said, must be 60 degrees. Forgot a C in that word right there. So if I told you that this is an equilateral triangle, okay, actually let's reverse that. If I told you this is an isosceles triangle, and I asked you to find all the missing parts, remember, if based off the information that we're given right now, this is an isosceles triangle. So I know that we have our two legs. I have my vertical angle, or my vertex angle, excuse me. But I know that these two angles down over here have to be the same because they are opposite my congruent sides. So technically, if I wanted to solve this, I could say x degrees, so x plus 60 equals 180. That becomes 2x equals 120, so x equals 60. Okay, which is angle P is 60, angle R is 60. Now that I know that all three angles are 60 degrees, I can then conclude that my then base side is the same length as my two legs, making this an equilateral triangle. So guys, technically, if we're like dissecting the definition, all equilateral triangles are isosceles, but all isosceles triangles are not equilateral because the requirements to be isosceles is at least two sides are congruent. And we know that equilaterals have three, so it actually meets the requirements of an isosceles triangle. Just looking at one more diagram, this one gets a little more complex, okay? But as we look at this, right, notice that my two sides are the same. So if I wanted to solve for y, my setup would be 4x minus 8 equals 6y plus 3. All right. Subtract the 4x, subtract 3. Looks like we're going to get some weird negative number here. So that would become negative 11 equals 2y, so y equals negative 5.5. I must have set up that equation wrong, guys, so that's how you would do it, but obviously we get into negative numbers. That's going to mess us up, but you guys get the idea. Now, also notice that the vertex angle F has the same equation as D, Right, guys, so my fault. I completely botched this diagram. There's something wrong here, because if I did 4x minus 8 equals 4x minus 8, that's going to equal 0, okay? But the key thing is just knowing that these angles would all be the same, making this an equilateral triangle. So before I cut this video, let's take a look at what the homework is going to look like for the night. So with this, notice there's lots of triangles within this diagram. And kind of remember what I said is that one of the key things is being able to kind of just dissect it based off the information that's given to you. So if we look at number 1, it's telling us that AC, which is this long side right here, is congruent to AD. So pretty much what we're looking at now is the big triangle ACD. And we know that that yellow length is congruent to this yellow length, which then means that the angles opposite those yellow sides are our base angles, making them congruent. So this angle would be congruent to this angle here. So that would be angle ACD is congruent to angle ADC. Now before I move on, I want to erase all of this so that I can remark my diagram fresh. So it's telling me that side BE is congruent to side BC. So as I look at that, I'm going to focus on triangle BCE for number 2. So when I look at that, angles opposite, okay, which would be this angle and this angle here. The angles opposite the congruent sides. So that would be angle BCE is congruent to angle BEC. And then again, I'm going to erase my work so that I can mark it fresh. Angle EBA, E to B to A, that's right here. Angle EAB is right here. Name 2 congruent sides. So now we're focusing on this triangle here. So see how you kind of have to work through it based on the information that's given to you. The sides opposite angle A is side BE. Oops, not angle, side. The side opposite angle B is side EA. And we know they're congruent because the angles opposite them are congruent. So guys, you're going to do numbers 1 through 8 on this one, and then there's actually a second homework to keep practicing this. Goodbye.